Hello friends, in the last video we have seen how to analyze a object when this object is moving on an inclined plane with constant velocity. Now in this video we will see how to analyze and write equation of motion if the object is moving with an acceleration on the inclined plane. So the objective of this session is to calculate the acceleration down the incline. So we have to calculate the acceleration. What is the magnitude of acceleration if an object is sliding over the inclined plane? And this we will illustrate using a problem. So the problem says, let us consider the toboggan as shown in the figure. So this is the toboggan that we have. The inclined surface has coefficient of kinetic friction mu k. So this surface is not a smooth surface, this is a rough surface, and kinetic friction coefficient is given, and this is mu sub k. Find the acceleration of toboggan in terms of z, alpha, w and mu k. So we have to find with what acceleration this toboggan is moving in the downward direction. And we have been given z, that is gravity, alpha, that is the angle of inclination, and w, that is the weight of the toboggan, and mu k is the coefficient of kinetic friction. So we have been given z, alpha, w and mu k. And what is my target variable? That is, what is my unknown? So we have to find acceleration of the toboggan. So this is the target variable. Now once again, how do you solve this problem? So we have to use Newton's second law because we have to find acceleration. So we have to find forces, and that will come from the free body diagram, and then we can relate force is equals to mass into acceleration. So the first step of solving this problem is to draw the free body diagram. So this is the toboggan. So let us denote this toboggan by a point, and this is my inclined plane, and this angle is given, this angle is alpha, and this toboggan is going in the downward direction. Acceleration is a. Let us assume this direction is my positive x-axis and this is my positive y-axis, that is perpendicular to the inclined plane. So the first force that is acting, that is weight of toboggan, that is W. And there is a normal reaction that will come, and this has value N. What other forces are acting? Since this toboggan has a tendency to go in the downward direction, there will be a friction force on the point of contact or surface of contact between this toboggan and inclined plane. And this friction force will act opposite to the motion. This means towards the up the incline. So this is the friction force that will act in this direction, and the value of this friction will be mu k times normal reaction. That is, this friction force is kinetic in nature. So now to write equation of motion, we have to decompose the forces. So in this direction we have to take the component of W. So this angle is alpha, then this angle will also be alpha. So this is nothing but W cos alpha. And in this direction the component will be W sin alpha. And then I have to delete this because we have taken the consideration, or we have taken into account this W. Now we have to write equation of motion. So let us write equation of motion in the x direction and in the y direction. So in the x direction I can write summation of forces is equals to mass into acceleration. So what are the forces that is acting? One force is W sin alpha. And friction is acting in the opposite direction, that is mu k times N. And this is moving in this direction along the x-axis with acceleration a. So we can basically equate this mass into acceleration. So mass of toboggan is m, and that can be calculated from the weight. Since weight is given, mass is equals to weight divided by z. So this is equation 1 from x direction. Similarly, we can write equation of motion in the bidirection. In the bidirection, we have one force normal reaction, and this W cos alpha is negative because this is acting in the opposite direction. And since there is no acceleration, this is equals to 0. So this is my equation 2. Now from equation 2, I can calculate n value and plug in equation 1. So from equation 1, I can write. So from equation 1, I can write W sine alpha minus mu k, and n is nothing but W cos alpha. So this is W cos alpha. This is equals to, and we said mass is nothing but W divided by Z times acceleration. So W cancels out. So we will have acceleration is equals to G comes this side, G times sine alpha minus mu cos alpha. So this is sine alpha minus mu cos alpha. So if an object, or in this case toboggan, is sliding in the downward direction, the magnitude of acceleration will be Z times sine alpha minus mu cos alpha. So this is the acceleration by which this toboggan is moving in the downward direction. Now we will consider different cases. Some special cases we can consider for this acceleration. So let us consider some special cases. The first case, when alpha is equals to 90 degree. What will happen in that case? Sin alpha is equals to 1, because alpha is equals to 90 degrees, sin alpha is equals to 1, and cos alpha is equals to 0, because alpha is 90 degree. Then what will the acceleration? In that case, acceleration is simply equals to z. And that makes sense, because what will happen in that case? This angle is alpha. If alpha goes to 90 degree, this means this is your surface and this is your toboggan. So this will fall freely. So when alpha is equals to 90 degree, you will have a free fall acceleration, and that comes from this expression, that is A is equals to Z. Now the second special case, when you will have acceleration is equals to 0. This means the toboggan will move with a constant velocity. So for that, you should have 0 is equals to sine alpha minus mu cos alpha. So what I am doing, I am simply equating this expression equals to 0. So from here I can say tan alpha is equals to mu. Or we can also say alpha is equals to arc tan or tan inverse mu. So if you remember, this was the angle that we derived in the previous video when the object was moving or toboggan was moving with a constant velocity. Now third possibility, when the acceleration can be negative. So there is a possibility that acceleration can be negative. So when acceleration can be negative, and acceleration is nothing but z sine alpha minus mu cos alpha. So this is possible for a smaller angles, a smaller alphas. In that case, this term will be large and this term will be a small. So if alpha is a small, because if alpha is a small, cos alpha will be large, and mu cos alpha can be greater than sine alpha. In that case, acceleration will be negative. What does this mean? Negative acceleration. Negative acceleration means this is the inclined surface and this is your toboggan, and even if you push this toboggan with some velocity, it will go into the downward direction, but the acceleration is negative. This means acceleration is in the upward direction. This toboggan will eventually come to the rest. So we can say for sine alpha is less than mu cos alpha, we will have negative acceleration, and in those cases, even though we push the toboggan in the downward direction, it will eventually come to the rest because of this negative acceleration. And finally, what will happen if the surface is smooth, that is mu k is equals to 0. So if mu k is equals to 0, plug in this expression mu k is equals to 0. So this is my mu k and this is also mu k. All mu are basically kinetic friction of coefficient mu k. So this is mu k. So this is also mu k. So what will happen in that case? You will have acceleration is equals to simply g sine alpha, because this term will be 0, so we will have only one term, that is g sine alpha. So let me check. If I have somewhere mu, then I have to replace with mu k. So this is my mu k and this is also mu k. So if mu k is equals to 0, acceleration is simply g sine alpha. That is your simple case that you have inclined plane and there is no friction on the inclined surface. In that case, object will move with a constant acceleration of g sine alpha. So in this video, we have seen how to analyze an object if it is moving or falling over an inclined plane and the surface has some friction coefficient, and we derive a general expression. Now this general expression can be considered and can be thought for different special cases, and these special cases we have basically learned or as a numerical problem in the previous videos. So you see, from the general expression we can derive all the special cases. For example, what happens when this inclined plane becomes vertical, what are the situation when acceleration will be 0, and what are the situation when acceleration will be negative, and what will happen if my surface is smooth. So you see, once I have a general expression, I can consider all the cases, all the special cases, and we can plug the values and we can derive the result for the special cases. I hope you enjoyed the videos, and if you enjoy this, please share with your friends, and I will see you in the next video. Thank you.